Hey everyone, my name is Brian, and I was a high school teacher. I now work with the Tennessee Department of Education. As a teacher, I taught biology and chemistry and physics. Most important for this video today, though, I am also a father to a 5-year-old and a 3-year-old who love Pokemon. So I'm going to use their Pokemon cards to talk about weather. Now, usually when we talk about weather, we think about things like clouds or we think about things like rain, and we'll get to those things eventually. But before we get there, we're going to start off by talking about what causes the weather, and that's something known as air pressure. So to help us understand air pressure, I've got a little demonstration, and that's where my Pokemon card comes in. I have a small little container, and I'm going to take this small little container, and I'm going to place some water into the small container. Fill it up to the very top. Now you can try this at home with any cup. You can use any type of card you want. You can use a playing card. I'm going to fill this up all the way, even if I spill a little bit. So you can use any type of playing card you might want. It's good if the card is slick and not like normal paper. All right. So now I'm going to take this playing card and I'm going to set it on top. And I'm going to push down. And here's where air pressure comes in. Because what we wouldn't expect is that if I turn this thing over, I can actually move that, and the playing card holds up the water. You see? Water is still in there. So how does that work? How does that playing card hold up the water? Well, the answer is the playing card is not holding it up at all. The thing holding it up is air pressure. And so to understand how air pressure works, we have to understand a couple of different things. We have to understand that air has weight. We have to understand that it has weight and it can push. And we have to understand that when it pushes, air is a little bit different than us. Because I can usually only push in one way or maybe push in two ways. Air, though, is special because it can push in all different ways at once. So let's see how this works, and let's visit those points. First of all, air has weight. How can we show that something that we can't see has weight? Well, let's do another quick little demonstration here in order to show that air has weight. So for this demonstration, I'm going to use some chemicals you might have in your house. Now, it's important to be careful with these, so have an adult help you if you want to do this. Now, I've got some extra science stuff around my house that lets me see some real small details. So I'm going to use a balance for this. So let me get set up and I'll rejoin you in just a second. All right. We are back, and what we're going to do is we're going to show that air, even though it's invisible, still has weight. So to do this, I'm going to use this balance here, and what you see right now is that there's nothing on it, so the weight is 0 grams. Now, if I take this container that has some baking soda on it, the weight is 30 grams. And if I add another container that has some vinegar in it, the weight goes up to 80 grams. Now, what we want to show here is that air, even though it's invisible, has weight. So what we want to do is we want to make some air here. So I'm going to make this by mixing my vinegar and baking soda. You already know that it forms these bubbles. Maybe bubbles are empty, or maybe you already know that bubbles have gas in them. So look at all these bubbles that we made. You even see some of them are bouncing around. We're still landing on that scale there. Now it's important to remember that Our weight was 80 grams. Oh, and hopefully we didn't overflow. Getting to the end here of all of our baking soda. Now, all my baking soda is in there. So when I set this down, I should go back 80 grams. Oh, and I ended up at 79. So somewhere we lost 1 gram. We lost some weight. And we lost that weight because of all that gas that left. So now we have proof. Now we know, we have evidence that gas has weight. And that's important to understanding air pressure. All right, let's leave the laboratory here and let's go back to think about something, which is that gas has force. So one of the things we had to understand was that gas has weight. And we saw that when the gas left the baking soda and vinegar, the weight of the thing went down because we were missing 1 gram of gas or 1 gram from that mixture. So the next thing we need to know in order to understand how it is that this Pokemon card can hold that water up is that air can push. And so to show that air can push, we have a real simple demonstration, and that's just really more of a thought activity. And that thought activity is thinking about the shape of this ball. So when air pushes on this ball, if air only pushed down, because we have all of this air above us, now how far does that air go? Well, that air actually goes all the way up into space. So here's planet Earth, and here is me. And then I have clouds maybe up above me. And then I have the very edge of outer space. All of this air, I'm going to imagine that I'm standing at the bottom of an invisible straw, and this straw goes all the way up into space. All of the air that's inside of this straw pushes down on me. And we're used to thinking of things pushing down when they have weight. We know that when we stand on a scale, we push the scale down. We don't think about air, which is special because it can push up. So think about the shape of this ball. If air was only pushing down on this ball, the shape of the ball wouldn't be round at all. If air was only pushing down, the shape of the ball would be more flat, like a pancake. The reason that the ball has a round shape is because air is pushing equally in all directions. So air pushes from the left side, and air pushes from the right side, air pushes from the top, and air even pushes from the bottom. So when air pushes from the bottom, and I do my demonstration, air is doing the same thing as my thumb. All the weight of the gas from here to outer space is pushing up on this card because air has weight, can push in any direction. Now, before we go, we might make a little mess here. Because when I did this demonstration the first time, we just used a little container. What if we try a bigger container? Let's try the same thing again. So, you can try as big a container as you want with permission from an adult. Now I've got this container filled all the way up with water. Now it's important that it's filled all the way up, so I'm even going to do some extra, even if I spill a little bit. So I have this thing filled all the way up. Now I put my card on top just like before, and that's a lot more water in there this time, but let's see what happens. It still works. In fact, it's easier to see even. So our final question then, how much water can we actually lift up? Well, let's go back to our picture here. Remember that we talked about being in the bottom of the straw and air pushing up. If we could take all of that air that's inside of this straw and weigh it, whatever the weight is of that water inside of the straw, or that air, inside of the straw that's up above us, that would be the same weight as the most water we could ever lift up. So if we said that this was 1 pound of water or 1 pound of air in here, then the most water we could lift is 1 pound of water. Maybe you can try something at home. Maybe you can mess with different containers that can all hold more and more amounts of water and see how heavy you think the air is between you and outer space. Thanks a lot. Remember, we're talking about air pressure, and now Miss Fong is going to go and do a little reading with us about air pressure.
Welcome, third graders. I hope you enjoyed Mr. Crane's demonstrations and were able to do some of them even in your own home. My name is Miss Swin, and I'll be Mr. Kane's teaching partner or co-teacher for the science unit. I've been an educator in elementary schools for almost 20 years. I live in Nashville now, but before that, I lived in California. You might be able to notice my California accent, which is kind of different than your Tennessee accent. I'm married and I have 4 children. 2 are grown and they're out of the house, a boy and a girl, I guess a young man and a young woman. And I have 2 boys at home, a 14-year-old and a 12-year-old, as well as 2 dogs who like to chill out at home now that the weather is not so great. So here are our learning objectives for today's reading. Describe characteristics of the air in Earth's atmosphere. Identify the 2 most common gases in Earth's atmosphere. Explain the relationship between warmer or cooler temperature and lower or higher pressure. So I have 3 goals for this lesson. I want to make sure I can do those 3 things after I read this chapter. Here's the book we're going to read for this unit. It's called Weather and Climate. Right. So on this cover, I see some sort of tool or instruments. Measure weather. I don't know what this lady is doing down here. Not really sure, but I definitely know this is snow. And then you can see lightning in the background. I think those are some of the things we'll probably learn about. Let's look at the table of contents. So here I can see that there are 8 chapters. I'm going to learn a lot of different things about weather and climate in this book. I'm going to learn about water and wind, how we can predict weather, different seasons and climates, and extreme weather, even engineering and technology having to do with weather. Wow, that sounds like a lot of interesting things that we'll be learning about. All right, chapter 1, the atmosphere and air pressure. So I'm noticing on this page before I start reading that I have some call outs here, or some things in the sidebar. A big question. What is the atmosphere and what is weather? Those are good questions, and luckily the title of this chapter is the atmosphere and air pressure, so I bet I'll understand more about those things as I continue to read this chapter. Suppose a friend asked you, what is the weather like today? What would you say? How would you know? You might say it's cold and raining. Weather is what the air outside is like at any one time and place. The weather can be clear and warm, cold and rainy, or dry and windy. So I see weather is in bold, so it's defined it for me in the paragraph. So weather is what the air outside is like at any one time and place. And I can see that under vocabulary in the sidebar, it definitely gives me that definition again. So if I forget, I can just look here on the side. You can observe the weather. You can look outside. You can collect rain in a container and measure it. You can find out which way the wind is blowing. Now, when I think about the weather in Tennessee, it's very different than the weather we had in California. For example, today it was sunny and hot and humid, and then it was cloudy and all of a sudden it started pouring. That never happened where I lived in California. During the day, it would be sunny and clear and dry, and really most of the time it was pretty pleasant. Not like here in Tennessee where we get to see lots of different kinds of weather. The weather in California was a little bit boring in that way. So let's keep reading. But what if your friend asked you, what causes different kinds of weather? What would you say to that? To understand what causes weather, we need to learn about the atmosphere. The atmosphere is the layer of air that surrounds Earth. Oh, I've got another bold word here. Atmosphere. So it's the layer of air that surrounds the Earth. Like the sky? Wait. Oh yeah, it goes all the way from here, all the way to space, like Mr. Kane had said in his video. That's right. So the atmosphere is about 70 miles thick. Most weather happens in the part of the atmosphere closest to Earth's surface. Oh, look at this picture. Do you see what looks like a thin, glowing blue line? That and the clouds you see are parts of Earth's atmosphere. You guys see it? It might be a little hard for you, but here's Earth. The black part is space. And here's this tiny, thin blue line. And that is the atmosphere. Now I see here it says that the atmosphere is 70 miles thick. That sounds like a lot, but it says in the picture it's a thin line. So why is that? Well, did you know that the Earth's thickness is actually 80,000 miles? So 80,000 miles is a lot. And then we have little 70 miles. And that's why the atmosphere is actually pretty thin when I think about it compared to the Earth itself. Air is matter. Oh, here's the heading, right, of this page. So I know it tells me what this page is going to be about, or this section is going to be about. So I remember from a different science lesson we had earlier in this grade level, or maybe it was last year. Anyway, so matter, I remember it being something about anything that has weight, and it has to take up some space, right? So I'm thinking then this section must tell me what kinds of matter there are in the atmosphere or in the air around us. So let's make sure we know what that is. The air that makes up our atmosphere is a mixture of gases. Gas is a state of matter. Air contains mostly nitrogen gas, but it also contains oxygen gas. Other gases such as water vapor and carbon dioxide are in the air too. So you never really see the air, it surrounds you every day and helps you to survive. All right, so what is in the air? Well, definitely a mixture of gases. And I remember this as being one of our big questions. So what's in the atmosphere? Well, there's nitrogen gas, oxygen gas, water vapor, and carbon dioxide. I wonder if there's anything else, or if those are just the main things. Like all matter, the gases in the air take up space. These gases of the atmosphere do not float out into space, though. That is because the force of gravity pulls air down towards Earth's center. Ooh, here's a sidebar, so let's make sure we read this one too. Think about matter. When you drink water, it's liquid. If you put a tray of water in the freezer, it turns to a solid ice. If you leave a tray of water out in the hot sun, it evaporates into a gas called water vapor. Liquid water, ice, and water vapor are all examples of different states of matter of water. Wow, that's pretty cool. And what's even cooler, I think, is that if the air is getting pulled down by gravity, then it's super cool that when Mr. came to the card trick with the cup of water, that like the water didn't even fall down like gravity would because of the air pressure he was talking about, which must be pushing against the gravity, which is pretty cool. You know what? I'm pretty glad that gravity pulls the gases down because otherwise we wouldn't be able to live without all those gases, right? All right. Ooh, have you guys ever seen these before? We used to have this where I lived out in California. Let's read this caption. What do you think causes turbines like these to spin? The pushing force of the wind provides evidence that air is made of matter, which can move and transfer motion energy to objects. Well, these turbines look like those windmills, or the old ones in the old stories that go round and round and round. So they farm the wind to get some energy from it. So it's pretty cool. I haven't seen any here in Tennessee, but maybe they are by where you live. Ooh, we have a new section because I've got a new heading. Air pressure. Ooh, Mr. King was talking about that in his his demonstration. So let's read more about it. Gravity pulls on air just like all other matter. That means that air constantly pushes against everything on Earth's surface. The weight of air pressing on objects is called air pressure. Right, Mr. Kane had said something about that before. Oh, and here it's a vocabulary word. The weight of air as it presses on objects below or within it. Air pressure is less as you travel upward and away from the surface of Earth. An object very high in the air experiences less air pressure than another object at sea level. That is because there is less air higher up in the atmosphere to press on things. Air pressure changes depending on the amount of matter in it. If more matter, air is above and surrounding you, then the air pressure will be greater. Air pressure is one factor that affects weather. Okay, so I'm a little bit confused. Maybe I should just read on because I'm not really sure how air pressure affects the weather exactly. Oh, I've got a picture on this page. Great. So I can see on this picture that there's sea level, there's a tall mountain. Oh, and it's labeled it for me. So here's the top of the atmosphere and has lower air pressure. Oh, I guess because there's less air up here. And then higher air pressure is down here by sea level. Oh, because look, remember that straw that Mr. Payne was talking about? Pretending it went all the way from where we are, all the way to the top of the atmosphere. Then I can see now how the top of the atmosphere just wouldn't have as much in it, or as much air in it. So sea level is the level of the surface of the ocean where water meets the land. Oh, that's sea level. Okay. That makes a lot of sense. But I still don't understand what that has to do with weather. I guess I'll just keep reading. So, changes in air pressure. Energy from the sun warms Earth's surface. So energy from the sun. What does that have to do with changing air pressure? It also warms the atmosphere. Do you know what happens to air when it warms? It spreads out. When air cools, it gets more compact, filling less space. Changes in air temperature and air pressure cause many of the conditions that we know as weather. Okay, so now it's air pressure and temperature that affect weather. When air pressure is high, the skies are usually clear and sunny. Low air pressure in an area is often associated with clouds, rain, or even snow. So we have high pressure, clear and sunny, low pressure, clouds, rain, and snow. So it says it's usually, right? Or it doesn't say, yeah, it doesn't say usually. I gotta think about that some more as I read. Oh, here's another one. Think about matter and temperature. Temperature is a measurement of how hot or cold something is. Typically, when matter increases in temperature, it begins to spread out. For example, when liquid water is boiled to become water vapor, tiny particles spread out so much that it becomes hard for anyone to see them. So yeah, when I boil water, for like when I'm making pasta or the tea kettle, I can see the vapor, boiling off. It's going up into the atmosphere, into the air around us, but then I can't see it anymore. I can still see the water, but I don't see the water vapor. So according to this text, it's just saying that the particles are just getting all spread out, so then I can't even see them because they're all bunched together like, in water. Now let's look at this picture. It says, how would you describe the weather? Do you think the air pressure in this area is high or low? I talked about that on the previous page, right? Well, I see a blue lake. The sky is blue. I don't see any clouds, so it's not raining. So I think it must have high pressure since I don't see any evidence of, bad weather. Yeah, I think that's what it says. Well, we've come to the end of chapter 1. But I hear that Mr. Kane has a couple more things he'd like to show you. So let's see what he's up to. And I will see you guys next time.